In this video we are going to do some exercises on linear combinations. So let us say we have a vector v, 1, minus 2, 5, and we have vectors a1, 1, 1, 1, e2, 1, 2, 3, and e3, 2, minus 1, 1. And let us write vector v as a linear combination of these three vectors. So this means that we want to write vector v as x times e1, y times e2, plus z times e3, okay, where x, y, and z will be scalars. Okay, so what do we have to do? So we can write 1 minus 2, 5 as a linear combination. So we'll have 1, 1, 1 times x, 1, 2, 3 times y, and 2 minus 1, 1 times z. So x times 1, it will be x, x, x. Y times this vector will be y, 2y, 3i, and z times this vector will be 2z minus z, z. Now we will add x, y, and 2z, right? First component, second component, third component. Okay, and we want all this to be equal to 1 minus 2, 5. Okay, so now we will have 1 equal to x plus y plus 2z, so x plus y plus 2z equal 1, x plus 2y minus z equal 2, and x plus 3y plus z, it will be equal to 5. Okay, now you can solve this system. The system is really easy to solve. You can take a matrix or whatever, or do some Gaussian elimination or something like that, and we will get to x being minus 6, y 3, and z 2. Okay, so looking here, so now x will be minus 6, y will be 3, and z will be 2. Okay, so vector v with these scalars will be a linear combination of these three vectors. Now let's do another exercise, exercise 2. We have vector v, 2 minus 5, 3, and we have vectors 1 minus 3, 2, 2 minus 4 minus 1, and 1 minus 5, 7. And let us try to write vector v as a linear combination of vector e1, e2, and e3. So let us try to write vector v as a linear combination of those three vectors. So this will be 2 minus 5, 3 will be equal to x times 1 minus 3, 2, y times 2 minus 4 minus 1, and z times 1 minus 5, 7. So that will be x plus 2y plus z minus 3x minus 4y minus 4z, 2x minus y plus 7z. And this should be equal to 2 minus 5, 3. So what we have here is x plus 2i plus z is equal to 2, and minus 3, 6 minus 4y minus 5z equal minus 5. 2x minus y plus 7z will be equal to 3. Okay, so if you do some quick calculations, you will get to this sort of result. Okay, so you can use a matrix for this. Actually, I use a matrix for this, but I'm writing this quickly here. So 0 equal 3, so this is impossible, right? So the system is inconsistent and so has no solution. So we can say that V cannot be written as a linear combination of vectors E1, E2, E3.